Hi fellas, this is Chemaddcts again to the solution. Welcome back to my another video tutorial. Well fellas, I'm really glad to hear that you have you are here to watch my another video tutorial. That's really appreciating. So let's get started. So today we're gonna solve chemistry rate problems. Okay. So we're gonna study unit 4 rate problems. Okay. So today's topic is about how to determine the order of reaction from the graph. So what we will do in this video tutorial? Well, we will discuss the basic concept of order of reaction by solving a problem. So what things we would learn from this video? We will learn about different patterns of the graph and what information can be obtained from those types of graphs. Okay, so at first let us check out the summary of this video. Here we will learn to solve a problem relating rates and order of a reaction, concentration of reactants. Define some of the useful terms about this topic. Apply the basic concepts of graph to find the suitable option. Analyze different graphs and extract valuable information from them. Avoid the mistakes, and finally we're gonna learn about avoiding the mistakes. Okay, so at first let us check the study questions for today. What is the study question for today? Let us check. So this is the study question for today. Okay, so which of the following graphs shows that a reaction is first order with respect to reactant X? Okay, so let's solve this question. So let us see what does the question ask. Okay, which of the following graphs shows that a reaction is first order with respect to reactant X? Okay, so this is the option given. It is, as you can see, it is MCQ type question. It is a MCQ type question. So they have given some of the options and they have asked us to find which graphs represent which graph will give us the first order with respect to reactant X. Okay, so among these options, there are four options. Among these options, which will give us the first order with respect to reactant X? Okay, there are four options: option A, B, C, and D. Okay, so among these four graphs, which will give us the information about first order with respect to reactant X? So before solving this problem, so let us check out some of the definitions involving this question. Okay, so now let us check out some of the important definition regarding this topic. So at first let us know what is meant by rates of reaction. Since we are dealing with the topic rates of reaction, so we need to know the definition of rates of reaction. Okay, so it is the change of concentration of reactants with respect to time. So rates of reaction is rates of reaction simply means change of concentration with respect to time. Okay, so simply rates means change of something with respect to time. Anything with respect to time is rates. Okay, so for this case, the change of concentration of reactants with respect to time is called rate. Okay, so here is another piece of information that we need to know. Rate is proportional to the initial concentration of the reactants. Okay, so rate is proportional to the initial concentration of the reactants. So fellas, as you already know that rate is proportional to the initial concentration of the reactants. Rate is proportional to the concentration of reactants. As the concentration increases, rate increases. As the concentration falls, rate falls. Okay. So here is the new thing that you will come across, that raised to appropriate powers, raised to some powers. So what does this mean? Okay, let us read this again. Rate is proportional to the initial concentration of the reactants raised to appropriate powers. Well, what does this particularly mean? Let us see. Here, order of reaction is raised to appropriate powers. Okay, so what does this thing mean? We will come across this thing later on. So at first, let us know what is meant by rate determining step. A reaction may involve many steps. As you all know that a reaction may involve many steps. Okay, so rate determining step is the slowest step. uh, Rate determining step is the slowest step. Determining step is the slowest step in the multi-step mechanism. So the rate determining step is the slowest step of in the multi-step mechanism. Okay, so the rate determining step is the slowest step in the multi-step mechanism. For example, uh, in a reaction there is a mechanism which involves many steps. So the slowest step would be the rate determining step, since we can determine the rate of the steps, since the step it has the slowest rate. Okay, so as you all know that we can easily track the reaction which is slow. We can observe the reaction which is slow, so that is why we can determine the rate easily by observing the slowest reaction. Okay, the step which involves a slowest reaction is called rate determining step. I hope that you have understood. So let us move on to the next definition, which is meant which uh, which is order of the reaction. Okay, it is number of particles involved up to and including RDS, rate determining step. Okay, we can see that rate determining step can be called RDS in short. Okay, so the particles, number of any particles that involved up to, it should be involved up to and including, it should also include RDS step. Okay, so the particles should be present up to and including the RDS step. Okay, you shouldn't avoid the RDS step, you should include RDS step. Okay, so that will give us the order of the reaction. So it is order of the reaction simply means it is the number of particles involved up to and including RDS, rate determining step. I hope that you have understood the definitions that are required for this question. Okay, so let us move on to the problem. So here they have asked us to identify the graph that shows that the reaction is first order with respect to reactant X. Okay, so let us examine each option separately. So at first, let us examine the first option, that is A. So at first, let us say which graph it represents. Okay, so here it is the concentration of X in the y-axis. Okay, this is the concentration of X and this is time. So easily you can guess that it is simply concentration time graph. Okay, so as you all know that concentration time graph, sorry, as you all know that the gradient is the rate in concentration time graph. Okay, so concentration time graph will give rate in the gradient. Okay, so the gradient is rate. The gradient of concentration time graph is rate. Okay, so in here, let us examine this further on. Let us dig deeper to this. So in here you can see that this is a straight line which is downward. Okay, so this means that the gradient, as you all know that mathematically, the gradient of a straight line is always constant. Gradient is constant, so therefore rate is also constant. Okay, rate is also constant, so therefore we can say that the rate is constant. Since the rate is constant, and we can see that the concentration, as the time moves on, the concentration of X falls. Okay, so therefore ultimately this will give the order for order of reaction, order of X is 0. Since the rate is constant, so the order of X will be 0. Okay, so therefore the X is not in the RDS. Therefore X is out of RDS. Since we know from the definition that order simply means the number of particles involved up to and including the RDS. Since the order of reaction is 0, since the rate is constant, so the order of X will be 0. So X is out of RDS, we know from the definition. And we also know that this X have no influence on rate. Since the rate is 0, sorry extremely sorry since the rate is constant, so X will not have any influence on rate. Okay, so rate is same for concentration of X. Okay, so in here we can conclude that the order of X is 0 in option A, so A shouldn't be the option. Okay, so let us move on. So I hope that sorry so I hope that you have understood the concept regarding this option. So A shouldn't be the answer. Okay, A is not the option. Okay, A is not the option, since this will give us the order of X is 0. So the order of X is 0 here. Since order of X is 0 here, so this shouldn't be the option. So let us move on to B. Okay, let us see what does B tells us. Okay, so at first let us see which kind of graph is this. So in here the y-axis is rate, and in x-axis this is concentration of X. So we can simply say that this is rate concentration graph. Okay, rate concentration graph. Okay, so this is rate concentration graph. This is just nothing, I have just miswritten it. So this is rate concentration graph. So what does this graph will give? Okay, let us see. So you can see that the line is horizontal over here. So what does this imply? So this implies us that the gradient is 0. Okay, so we are not concerned about the gradient over here, since this is rate versus concentration of X graph. So the gradient doesn't have any significant value, so we will ignore that for this moment. So now let us check what does this gives us, what kind of information, what does this gives us about the information of order of the reactant X. Okay, so we will focus on the order of reaction of X. Okay, so let's see. So if you can see that the rate is constant, since this is horizontal, so the rate is constant throughout the time. As the concentration changes, the rate doesn't change, the rate is constant here. Okay, rate is constant. So therefore we can see that this is zero order reaction for X. Okay, so X is zero order, X is zero order over here. Okay, sorry, I have again made the mistake, display for that. So X is zero order. So from before, uh, just like before, we can also say that X is out of RDS, so X is not involved in the RDS. Okay, so it is out of RDS and it has no influence on rate, since the rate is constant over here. Since the rate is constant over here, so X have no influence on rate. Okay, so here a rate against concentration of X is plotted. Okay, so here there is another thing that you need to know, that reaction is happening. Okay, so the reaction doesn't stop over here, the reaction still carries on. Okay, throughout the time the reaction still carries on. But let me tell you one thing, that some of the students get confused with this graph with another one, that is concentration time graph. Okay, so I'm gonna discuss that thing right now to remove your confusion. Okay, this is, let me tell you one thing, this is rate concentration graph, and the horizontal line doesn't mean that the reaction has stopped. Okay, the reaction is happening with respect to time, and the rate is constant. Okay, the rate is not zero over here. Okay, so let me draw another graph for you. Where is it? Here, it's over here. Okay, let us compare. uh, for this case it is concentration time graph. Okay, this is concentration time graph, this is concentration time graph. Sorry fellas, these this video would be longer since I'm talking about each and every option separately. I'm really sorry for that. I am discussing in details about this topic. Most of the student faces trouble about this topic. They get confused since there are lots of graph in about on this topic. There are lots of graph on this topic, and they get confused about the structure. Okay, so I'm really sorry for that. The video would be quite lengthy. Okay, so I hope that you will continue watching. Don't get bored. Okay, so this is concentration time graph. So in here this should be horizontal. So what does this horizontal mean? So at first here the gradient is rate. Okay, we all know that the gradient of concentration time graph is rate. Okay, so in here the rate is 0. Rate is equals to 0 in here. So let us compare this graph with this graph. So in here the rate is constant. Okay, here the value for rate is constant, but in here the rate is 0 since the gradient over here is rate. Since the gradient is 0 over here, so the rate is also 0. And in here the gradient is not rate. The gradient is not representing rate. So the gradient is 0 over here, but rate is not 0. Okay, since gradient is not rate. Okay, so here the rate is constant, and over here the rate is 0 since the gradient is equals to rate. So rate is 0. Okay, so gradient is equals to rate is equals to 0. So since there is no rate, so there will be no reaction. As you all know, since there is no rate, there will be no reaction. No reaction, no rate. Okay, no money, no honey. Just kidding. No reaction, no rate. As simple as that. So most of the students get confused between these two graphs. Okay, so in here the reaction is happening, but in here reaction is not happening. Okay, or in other words we can say that the reaction has stopped. Okay, since there is no rate, the reaction has stopped. As simple as that. Okay, well, let me see, did I miss anything or not? Okay, fellas, I have worked really hard on this, so please do appreciate by watching the full video tutorial. Okay, I'm telling this once again that the video tutorial will be longer than normal. I'm really sorry for that. I will discuss each and everything, each and every point regarding this topic to make your concept clear. Okay, to make things clear. Well, so everything is done about option B. Okay, so I hope that you have understood. Where is my pen? There is my pen. PPAP. Nice joke, right? You get that joke. Okay, so I hope that you have understood the concept regarding the option B. So B shouldn't be the answer. Okay, so here the order of x is 0. So it is 0 order reaction. so B shouldn't be the answer. Okay, so let us move on to C. Alright, so as you can see that there each and every option has different structure of graph. Graph has this different structure in different options. So let us study one by one. Okay, so we have studied two graphs before, so now we're gonna study the third option. Okay, so at first let us mention what does this represent, what does this graph represent. So this is concentration time graph. Okay, so what does the gradient gives us? The gradient is simply rate. Since this is a concentration time graph, so the gradient would be rate. Okay, so here it is curve. Okay, so before we in A we have seen that the concentration time graph has the straight line, and in over C we have seen that it is curve. Okay, so let us examine this thing. So graph, here the graph is curve, not a straight line. Okay, graph is not a straight line, as simple as that. So these graphs generally generally represent first or greater orders. Okay, so before we have seen that the graph is straight line for first order, sorry, the graph before we have seen that the graph for zero order is a straight line for concentration time graph. In concentration time graph, the graph is straight line for zero order. But in here, in concentration time graph, this concentration time graph will have a curve graph or non-linear graph for first or greater order. Okay, so I hope that this makes you clear. Okay, so this will have first or greater order. It's been already 27 minutes. I'm really sorry for that, so do bear with me. Okay, so this graph is generally for first or greater order. Okay, so the gradient here is not steep. Okay, if you have noticed, the gradient is not that much steeper. Okay, and if you have noticed, if if you want to find the half-life, okay, well, let me tell you one thing what is meant by half-life. Half-life is the time taken for the initial concentration to become half, just like radioactive. In radioactive you have learned about half-life. Half-life is simply means the time taken for the initial concentration to become half. Okay, it is for the chemical terms. In chemical terms we use half-life as the time taken for the initial concentration to become half. Okay, so this is the initial concentration and here it becomes half. So this would be the half-life. So from here, so in here we have considered this as initial concentration. So for this is the half concentration. So here we have found T1. Okay, so we will now consider this as initial concentration and the half concentration would be this. Sorry, here. So this is the concentration T2. Okay, so if you have noticed, the half-lives are constant. So for first order reaction, this is first order reaction. Okay, this is first order reactions, since half life is constant. Half life is constant. Okay, and the gradient is not steeper. Okay, not much steeper. So we're gonna look on to for greater or second or greater order, okay, for the graph later on. So for this, for the time being, we're gonna say that the gradient is not much steeper. Okay, so let us now move, so let us check what will be the graph for greater order. Okay, so let's see, this is the graph for first order. So this would be, sorry, my drawing is not good. this this would be the graph for second order. Okay, and this is the graph for third order, and this goes on and on. Okay, as you can see that as the number of orders increases, order number increases, the graph becomes more steeper. This graph is more steeper than this one, and this graph is more steeper than this one. So greater number of orders will have non-constant, half-life will not be constant anymore for greater number of orders. So the first order will have, only first order will have uh, half-life constant half-life. First, only first order will have constant half-life. Besides first order, the greater order, second or greater order will have non-constant half-life. Okay, so do I have missed everything? Sorry, do I missed anything? Let me see. I know that my English is really bad. I'm really I'm really bad for that, fellas. I'm really sorry for that, fellas. Okay. So this graph is generally for first order, as you all know that in here this graph is mainly for first order. Okay, since the half-life is constant over here and the gradient is not steeper than this one. Okay, so the gradient gets steeper with greater number of orders. Okay, you may order pizza, just kidding. So now let us move on to D. Okay, so let us check what would be the graph for D. So this is rate versus concentration of X graph. Okay, so this will have, so the gradient will be insignificant over here. Okay, the gradient doesn't mean anything over here, the gradient is not important here. So the what is important is the shape of the graph. Okay, well, I have forget to mention one thing. So order of the reaction determines the shape of the graph. If you have noticed in A B C D, if you have noticed in option A B C and D, the order of the reaction determines the shape of the graph. Okay, so different order have different shapes. Okay, so order of reaction determines the shape of the graph. Okay, so the order of the reaction determines the shape of the graph. So in here this is rate against concentration of X. So the first order will give the straight line. First order will give us, sorry, first order will give us straight line. Okay, since the half-life is constant, so the first order will give us straight line. Okay, just like this. So this is rate against concentration. So the straight line will give first order. This is first order. Okay, second or greater order will give us curve. Okay, second or greater order will give us curve. Okay, for rate concentration graph. So second or greater order will give us curve. So this is not the first order. Okay, this is second or greater order. Since here rate is not proportional to the concentration of X. Okay, we also know that for first order rate is proportional to concentration of X. Okay, so here rate isn't is not proportional to concentration of X. Okay, so the rate is not proportional to X. Since the rate is not proportional to X, here the rate is not directly proportional to X, so we can confidently say that this is not first order. For first order, the rate is directly proportional to X. Here the rate is directly proportional to X for first order, as you can see by looking at the graph. So this is not the first order graph. Okay, the first this does not imply us that this is not the first order. This is second or greater order. So now let us see the option C. Since here since this is the only option left, this curve might represent first order. Okay, so this should be the answer, since here the time half-life is constant over here and the gradient is not steeper, so this should be the answer. Okay, the gradient is not that much steeper. Okay, so this would be the answer. This is the first order. This graph represents the first order reaction. Okay, so therefore this graph represent first order reaction. Okay, so C would be the answer. Okay, and let me tell you one thing, that this is the graph for concentration time graph, and this is the graph for concentration time graph, and this is the graph for rate time graph. If we plot this on rate time graph, the graph would be like this, straight line. So in other word, we can say that for first order reaction, okay, for first order reaction, rate, sorry, my handwriting is really bad, I'm really sorry for that, fellas. So rate is directly proportional to time. Okay, sorry, this should be concentration. I know, I make mistake frequently. Really sorry for the human makes mistake, man. Human makes mistake. Okay, you are my fellows. Okay, you should understand. So who will understand beside you? Human makes mistake. So rate is directly proportional to concentration. For first order reaction, rate is directly proportional to concentration. So if we plot this on rate concentration graph, so this will give us the straight line. Okay, so C would be the answer. So fellas, I hope so. Fellas, let us see which should be the answer for this question. So the answer should be C. Okay, the answer is C. Okay, the question asked about, let us read the question once again. Which of the following graphs shows that a reaction is first order with respect to reactant X? So this should be the answer. So this gives us the information about first order. Okay, this graph gives us the first order reaction. Okay, so fellas, the this video is quite lengthy since we have discussed in details about the concept, because most of the fellas face problems regarding this topic because it's really confusing. It also really confusing to me because there are really, because graph has different patterns for different conditions. So I hope that you have enjoyed. So fellas, thanks for watching. Okay.